Hello dear friends, welcome to BYJU'S Exam Prep and I welcome all for this GATE Mathematics special series on probability. We already completed the basic probability. Now today we are going to start with advanced probability and we are going to see the introduction of random variables. Okay? And this is one of the important topic for GATE point of view. So I'll give you the idea of random variable in a nutshell and how to attack the problems based on this when they ask in your GATE examination. We try to understand. Okay, and please mention you are all able to hear me. Am I audible, loud and clear? My voice and my video is loud and clear. Yes? Yeah. So this is about random variable, sir. Hi sir, good evening, very good evening, Supriya. Yeah. And this is about me, myself Sridhar Sir. I am having 20 plus years of teaching experience and my qualifications are given here. I am Tech Saka from NIT Karnataka Circle and MSc Mathematics from JNTU Hyderabad. Thank you sir, thank you very much. Very good evening Sharon, Supriya and Sharon. Very good sir, well done. Thank you. Okay, and I am working with BYJU'S from past 1.5 years. We are working on this particular project called GATE Recorded Content. The first of its kind. We created visualized animated content. Under BYJU'S Exam Prep app, you can see these videos under the category Learn with Video Lessons. I recorded all the subjects: engineering mathematics, discrete mathematics, algorithms, C and data structures. Okay, my dear friends. Okay, right. We are coming up with this series called GATE Formula 1 series. The most important formula will be discussed for all the branches, of course including my parent batch, that is CSE also. Am I clear? We will be coming up with this Formula 1 series from 12th October. Please subscribe to our channel and press the bell icon so that you can get the notification for these classes. Wow, sir, thank you. Thank you, Supriya. Thank you. Well done. Right? So, we start with today's class without wasting any of your time now. Right? Random variables. See my dear friends, I generally call it as advanced probability. Here the idea is simple. We are having a random experiment. Okay, the outcomes of the random experiment are called sample space or outcomes or sample points also people call them, and the collection of all those outcomes becomes your sample space. Collection of all those outcomes becomes sample space. Now, when you roll a die, can you tell me what are the outcomes? When you roll a die, what are the outcomes? These points which I am telling you are the most important points. If you understand, you will understand why the random variable topic is very simple. Okay, most of the people are having some misunderstandings. Okay, they always do this particular topic in a wrong manner, the wrong approach. So I am trying to tell you in a nutshell what is this random variable, how to attack problems on this particular topic. Right? Random variable. Okay, when you roll a die, I ask you this question: when you roll a die, what are the possible outcomes? If you need to answer my questions, my dear friends. Okay, you need to answer my question. What are the possible outcomes when you roll a die? 1, 2, 3, 4, 5, 6. Mukhopadhyay, very good sir. 1, 2, 3, 4, 5, 6. These are the outcomes. Now, outcomes are actually not 1, 2, 3, 4, 5, 6. 1 dot, we refer it as 1. 2 dots, we refer it as 2. 3 dots, we refer it as 3. Like that. Okay. Anyhow, somehow they are numbers. We are happy. Mathematics people are happy with the numbers. Now you toss a coin. What about the outcome? What about the outcome? When you toss a coin, what about the outcome? Tell me what is the outcome. When you toss a coin, what are the possible outcomes? Head or tail. Now here head or tail are not numbers. So mathematics people are not happy with these outcomes. So the idea of random variable is simply converting outcomes to numbers. Idea of random variable is simply converting outcomes to numbers. Because mathematics people like numbers, they want to work with numbers instead of working with heads and tails. So we associate the outcomes to a number. We associate outcomes to a number. And how you associate? Using a function. And that particular function is what is known as random variable. Random variable is a function which associates real numbers to outcomes of a random experiment. We are converting outcomes to numbers. That is the story. Now, in a nutshell, let me tell you the entire story of random variables. We are having a random experiment. Using random variable, we convert these outcomes of, see, whenever you have a random experiment, we are having outcomes. So, we get a sample space. Now, using random variable, we convert these outcomes to numbers. Okay? So, these are called the random variable values or values of the random variables. Am I clear? Using a function, we convert these fellows to numbers. Now, instead of associating probabilities to outcomes of the sample space, we associate probabilities to these random variable values. So, using what? Probability function. So, we use probability functions to associate probabilities to the values of the random variable. And this particular association is what is known as probability distribution. This particular association is what is known as probability distribution. So we are going to get from this, we are going to get probabilities, and this is going to give you what is known as probability distribution. Probability distribution. Now why I am writing 2 times, sir? Because depending on whether your outcomes are discrete or continuous, the distribution also we get 2 types. One is called discrete probability distribution, the other one is called continuous probability distribution. So this is the story, my dear friends. And in this topic we are going to discuss this. And what plays very important role? Random variable. And many people solve problems on random variable even without knowing what is random variable. Okay? So that is the advantage with mathematics, I can say. Right? You don't even know what is random variable and you can solve problems on random variables. But let us not do that way. Am I clear? Let us understand. Then you can solve many problems very easily. Okay? Without understanding by formulas also many problems in mathematics can be done very easily, sir. But if you understand, you don't have to solve many problems. Okay? That is the main agenda. Got it? So the random variables converts outcomes to some numbers. Okay? And to these numbers, we associate probabilities using what is known as probability function. And to outcomes or the values of the random variable, we are assigning probabilities. We get a distribution, and these particular distributions are known as probability distributions. And the story is all about probability distributions, my dear friends. And who is going to give you this probability distribution? Who is going to give you this probability distribution, my dear friends? Who is going to give you the probability distribution? Who or what, whatever you call it. What is going to give you the probability distribution? See, story is very simple, sir. I am trying to make it in a very, very simple sense. You will understand, what is random variable, and when you solve the problem, you know what is random variable. And what not random variable don't give you the distribution. Probability function will give you the probability distribution. Shivanada, random variable don't give you the distribution. Probability function will give you the distribution. But without random variable, what is the probability distribution? So because of that, people say random variables gives you the probability distribution. There is nothing wrong what you said. You can say like that also. There is nothing wrong. But if you want to understand properly what gives you the probability distribution, the probability function. So here only 2 important things we need to understand. What is the random variable? What is the probability function? Those who understand these 2 things can play with this topic. These are the 2 important things which actually going to decide everything. The random variable and the probability function. the random variable and the probability function. Okay. Now, as we understood, random variable can be categorized into two parts. One is called discrete probability distribution, or random variables we are talking about. Random variables can be classified into two types. One is called discrete random variable and the other one is called continuous random variable. See my difference. When you toss a coin, outcomes are head, tail, discrete values. Okay. Now, if you are counting or you are trying to see the telephone call duration, you are seeing the telephone call duration. Am I clear? Your experiment is telephone call calculating or counting, whatever you call it, telephone call duration. Random experiment is calculating telephone call duration or how long this particular, what do you call this? Okay, what do you call this? Remote or whatever it is. This fellow works. How long this fellow works, or how long this pen works, how long my mobile works, all these fellows. See here, can you say the discrete values? Can you say, yeah, pointers, whatever it is, how long this fellow works, this pen, let us say, how long this fellow works? Can you say discrete values, 1 hour, 2 hours, 3 hours, like that? Is it a discrete value? Is it a discrete value? See, when you toss a coin, outcomes are head to tail, discrete values. Whereas here, how long this pen works? Okay, we pray that during the class time it won't stop. During the class time it won't stop, so that we will not have any problem. Right? How long this works? Can you say it as discrete value? It can take any value. Suppose I started here, starting from 0 to, maybe suppose they may give 2 years warranty, 3 years warranty, you may say that. Or you can say infinity. You can say infinity. 0 to infinity. How long it works? 0 to infinity. How long this pen works? 0 to infinity. See here, in probability, when you say infinity means very large value. Mathematically that is infinity, but here practically that large value may be maybe 2 years or 3 years or 10 years, something like that. Is that clear? Hope you understand. So a discrete random variable is one which assumes countable values. Discrete countable values. Whereas a continuous random variable is one which assumes or which takes continuous values in an interval. It takes values in an interval. See, values in any interval, 0 to infinity. 0 also included now. See, I purchase this, first time when I start working, it may stop. So, it is failing in 0 time. 0 to infinity. Like that. So, random variables are of two types. One is called discrete random variables and the other one is of type continuous type. We call them as continuous random. Am I clear? Right? Now, so let us take the example of a discrete random variable, sir. First of all, so that you will understand how you get the distribution properly. How you get the distribution properly, now I will explain with the simple example. Okay. Now I conduct this particular random experiment tossing a coin twice. I conduct this particular random experiment tossing a coin twice. I am tossing the coin how many times, sir? 2 times I am tossing. I am tossing this particular coin how many times? 2 times I am tossing. And you all know what is the sample space. Set of all possible outcomes. Head head, head tail, tail head, tail tail. These are the possible outcomes. You like these outcomes? You like these outcomes? No one is answering. You can just say yes or no, no? Like it or not like it. Simple thing, no? See, the things which I am saying matters. People generally ignore these kind of statements which I give, but these are very important. Okay, because the random variable purpose is someone don't like these outcomes. That's why they introduced random variable. They converted them to numbers. Am I clear? Mathematics people don't like these outcomes. Am I clear? That's why they converted them to numbers. So we are converting them to numbers using random variable. Now the duty is defining a random variable. We need to define a random variable. So how I am defining a random variable, sir? I am defining a random variable like this. This is my random variable which is defined as I am counting number of heads. I am counting number of heads. See my dear friend, generally people take number of heads or number of tails. It is not necessary that we take number of heads, number of tails. You can count the difference between heads and tails. Okay, you can do what are the possible values of difference between heads and tails, sir? Heads minus tails. Absolute difference. The difference can be 2, difference can be 0, difference can be 1. Correct or not? Like, so here number of heads I am counting. See, you can do number of heads plus number of tails also you can do it. That is also random variable. I am just converting the outcomes to numbers somehow. So the simplest one I am taking, that is number of heads, the most popular random variable I am taking. I am taking the most popular random variable. Now what it will do, sir? What it will do, sir? What values this random variable will take? It counts number of heads. How many heads here? 2 heads. How many heads here? 1 head. How many heads here? 1. How many heads here? 0. So this random variable takes the following 3 values. This random variable takes the following 3 values. 0, 1, 2. So I converted the outcomes to numbers. I converted the outcomes to numbers, my dear friends. Is it clear? Yes or no? Now the first work is completed, converting outcomes to numbers. The second work is associating probabilities to the random variable values. Associating probabilities. How to associate probabilities? Now here x takes values what? It takes values 0, 1, 2. Now I want to associate probabilities, my dear friends. That is px here means, here when I say px it means probability that the random variable takes the value x. That is how I am defining probability, my dear friend. What is probability that random variable takes value 0, sir? See, random variable taking value 0 means probability of 0 heads. Probability of 0 heads. What is probability of 0 heads, my dear friends? What is probability of 0 heads? What is probability of 0 heads? When you toss a coin 2 times, what is probability of getting 2 heads? You are all here. Total 4 outcomes. Out of that, 1 is favorable for 0 heads. 1 by 4. Very good. SWFS. Very good, sir. Now please tell me, what is probability of getting 1 head? What is probability of getting 1 head? 1 head is, because 1 head happens in 2 situations, 2 favorable out of 4. 2 by 4, which is 1 by 2. Kunki, it is not 1 by 4. I think you might be giving answer for previous one. 1 by 2. Very good. What is probability of getting 2 heads? What is probability of getting 2 heads? 2 heads means 1 favorable out of 4. So this particular probability function is creating a distribution. It is creating what? It is creating a distribution, and we call it as a discrete probability distribution. It is creating a distribution which is called discrete probability distribution. And how you created this discrete probability distribution, sir? Using probability function. And who created this probability function, sir? We modeled from the given problem. The important point to be noted here is, at a basic level, for a given random variable, from the given situation, we can find probability function, my dear friends. Means we can find the probability function. But it is not our job here to create probability functions for a given random variables, my dear friends. Those who understand this, your life will be very simple. See, we need to understand the idea of probability function. That is, probability function associate probabilities to the values of the random variable. But creating probability function as we done here is not our job. Kiran, Kunki, you are late to the class or what? I counted number of heads, number of heads. That is how I given that. Number of heads. Outcomes when 2 heads. What are the possibilities? Because you can get 2 heads, or you can get 1 head, or you can get 0 heads. That is how I given the values. Am I clear? See, creating this probability function, maybe in the simple examples you can do it, but that is not our job. Our job is to use the probability function. And for discrete random variable, this probability function is given a special name. We call it as probability mass function. See my dear friend, this probability mass function generally will be given to you. Generally the probability mass function is given, and we have to use that probability function to answer the given question. Maybe at basic level you create your probability function, but please remember, this is not our job. We are not learning the modeling here. We are only using PMFs, my dear friends. You may solve 2-3 simple problems where you create probability function for a given random variable by observation or by calculations or by understanding probabilities. But that is not our job, please understand. Am I clear? They'll give you probability mass function. You have to use that probability mass function. Or you need to understand that your problem is in a particular format or following particular distribution, and for a particular distribution you know probability mass function, so you use it. So these are the two things which we need to do it. They give you probability mass function, you can simply use it. Or your problem follows similar pattern of a standard distribution. Your problem follows similar pattern of a following a particular standard distribution. Then you should identify that particular pattern, and you should identify your problem is following what distribution. Maybe binomial, maybe Poisson distribution. If it is a continuous case, it may be following uniform distribution, it may be following exponential. You identify the pattern and understand that your problem is following that particular probability distribution. Once you identify, observe that your problem is following that particular distribution, for that PMF is ready or PDF is ready. That is, probability function is ready for standard values. Again, you use PMFs or you use that particular probability function. Those who understand this idea, the advanced probability is very simple. Either they give you, or you need to understand your problem is following a particular distribution, and for that distribution probability function is fixed, so you use it. So ultimately you use probability functions. Is the idea clear? Is the idea clear? Now let us take a example for a continuous probability distribution. Now let us take example for a continuous probability distribution. As I told you now, how long this particular pen works, or you can consider this random experiment duration of a telephone call. You can consider this particular random experiment like duration of a telephone call. Now, for duration of a telephone call, how you say, sir? How you measure? I talk for less time, very less time, long time, very, very long time, too much. Is it like that you are going to describe that? Am I clear? So, telephone call duration is, calculating telephone call duration is your random experiment. Okay? So, it takes some values. Now, if you want to create some numbers to that, you cannot use that long time, very long time, very, very short time like that. No. So, we need a measure for that. So, here I create a random variable. Here I create a random variable. And what is that particular random variable, sir? The call duration in minutes. The call duration in minutes. Now, please tell me, what about this particular call duration, my dear friend? What about this particular call duration? How long it takes? Call duration, now I put it in minutes. Now please tell me, is it going to take 0 minutes? Otherwise exactly 1 minute? If it is not 1, exactly 2 minutes, is it like that? Is it discrete values? Is this function or the random variable which I created, does it take discrete values or a continuous values? Is it going to take discrete values or continuous values? Is it going to take discrete values or continuous values? Obviously it is not going to take, like, only your call duration is exactly 0 minutes, otherwise exactly 1 minute, otherwise exactly 2 minutes. It's not like that, no? It may take any time. Am I clear? It may take any time. Suppose if you are talking with your parents, the call duration will be very less time. And some calls will never end. Am I clear? Yeah, it takes continuous values. So this x takes values from 0 to infinity. Infinity means practically very large value. Theoretically infinity, practically very, very large value. For some problem infinity may be 10, for some problem infinity may be 100, for some problem infinity, practical infinity I am saying, that practical infinity may be 1000. Yes. Okay, Mahi, your call duration may be fixed time. I think Mahi's call duration may be fixed time. Okay, it may not go beyond 6 minutes. Okay, but it is not like that, sir. You're not used to all the type of calls, my dear friends. You are used to only, fixed type of calls. So you should grow up now. Then you will know all the different types of call durations. Am I clear? Or as I told you now, for Mahi it may be 6 is the infinity. 6 is the infinity for him. Am I clear? It may happen. Right? Hope you understand. Okay, I think we already have this. So let me remove this. Call duration in minutes. Hope you understand. Super. So this may take values from 0 to infinity. So 0 means missed call. Got it? Now, okay, you have this particular doubt. For the previous one, we properly given the probability function. Now, how to assign the probability, my dear friend? X taking value 0 to infinity. How to assign the probability? Because it is not a discrete value, X takes continuous values from 0 to infinity. Now, I give you a probability function, sir. I give you a probability function. And this is my probability function. Because here it is not discrete values, you cannot write discrete table here, sir. Because X takes continuous value. So the continuous function we need to create, my dear friends. And how you know that this is the function for this particular problem? How you know that this is the function for this particular problem? Anyone having any idea? How you know that this is the function for this particular problem? See, technology is improved so much and still you are asking faculty for the PDF. Personally, you ping me. Okay, this is my Telegram channel or Telegram group. Personally, you ping me. I cannot share it in the groups, even if I am having. Okay, so please ping me separately. There you find my name. There I can share you. Got it? You want only book या solution manual, right? This one. Please answer this question, sir. What about this fx? What about this fx? See this fx. Some people say initially we talk more, later on the talk time will be reduced. It's not like that, my dear friend. I don't know how you get this particular function. Someone modeled it. I am using it. Someone already modeled this. Yeah, 0 to infinity. Because of that, someone modeled it. I am using it. That's what I am trying to tell you, my dear friend. Most of the people are having this particular confusion. When we give a PDF, they worry about how you get this PDF. But this story or this course is not about how you get the PDFs. That is called modeling. Okay, that is real world modeling for a particular problem. That we are not learning here. We are going to learn how to use PMF. How to use this particular function. Okay, here because it's a continuous function, you call it as PDF. You call it as PDF. Our work is how to use them, not to create them, my friends. As I told you, for simple problem you may create it, but that is not our job. Our job is to use these functions, not to create them. Those who understand, it is simple for you, my dear friends. This course is very simple. They give you the problem. Okay, if it is directly PMF or PDF, depending on the continuous or discrete or continuous is given, you use it. Otherwise, you try to observe your problem is following what distribution, which pattern it is following. Accordingly, you say, okay, this fellow is following this particular distribution. I will use this PMF or I use this PDF. That is probability function of that particular distribution. This is the story, my friends, in a nutshell. Okay, if you understand, rest of the story is simple. It's all about, if function is given, directly use it. Otherwise, interpret your problem to a particular distribution. Cow story we call it. Got it? Now story you see here. You have a random experiment which gives you a sample space. Random variable converts the outcomes to real numbers. Then probability function associate probabilities to these random variable values. And hence you are going to get the distribution. And there are two types of distribution. One is called discrete probability distribution. The other one is called continuous probability distribution, depending on your problem. and that is the story. And this px, this fx creation is not what we learn in this course. At a basic course, we don't learn how to create them. Our work here is how to use these functions. How to use this function. If you understand, it's a simple story. Those who don't understand, worry about, creating PMFs. Okay, the first example which I given, they feel that, okay, I need to create PMFs. They feel that I need to create PDFs. You are not at that level, sir. That is called modeling level. We are not at that level. We are only using the given functions and solving the problems. That's simple story. That is our level, right? That's it. Now, probability mass function, PMF. See, if it is a discrete random variable, the function, that is probability function, is called probability mass function. As I told you, our job is not to create them, our job is to use the function. Probability mass function is used for discrete probability distributions, whereas probability density function is used for continuous probability distribution. Both are probability functions only, sir. They assign probabilities to the random variable values. If it is discrete random variable, you call that probability function as probability mass function. If it is continuous random variable, we call that particular probability function as probability density function. That's nothing more than. Now, as I told you, our job is to use them. So, if you want to use, you should know about it. If you want to use, you should know some properties about it, and that we should know. The probability mass function of a discrete random variable taking values x1 to xn is defined in such a way that the probability of any random variable value should be greater than or equal to 0. So, for any particular value, probability should be always greater than or equal to 0. Second one, sum of all the probabilities. Suppose if it is taking values x1, x2 and so on xn, no? So, px1 plus px2 plus and so on pxn. This is what we call it as sum of all the probabilities. This should be equal to 1. That's it. So, probability mass function mainly satisfies these two properties. It should be always giving positive or 0 values, and sum of all the probabilities must be equal to 1. See, obviously sum of all the values must be equal to 1, and it is positive and or equal to 0 means the probability can never go beyond 1. That is simple logic. Of course, PXI, that is very definition of PXI means what, sir? PXI means what? Probability that random variable x taking the value x. And we are not going to create it every time, sir. We only use this. We use this function. It is given, or your problem may be following some distribution. For that, already this function is ready. We use it. That is our job. That is our job, my dear friends. We don't create it. Those who can remove this creation idea, like those who feel like we are creators, okay, can never learn probability here, sir, because we are not creating them, we are using them. Our job is to use them. Our job is to interpret your problem to a particular distribution. Once it is interpreted as that particular distribution, thus functions, everything is ready. Again, use them. Again, the story is use them. Now look here. Who given PMF? Here I am having a discrete random variable. Okay? And Px is probability, sorry, it should be mass function. Of course, if they write density, don't worry about it, sir. It should be called as mass function. For discrete distributions, it is called as probability mass function. What is the value of K? Here, I not created, it is given. So, he clearly given PMF. I just use the properties of PMF to find the value of K. What is the property which I know, sir? Sum of the probabilities must be equal to 1. What are the sum of the probabilities? K plus 2k plus 3k plus 4k is equal to 1. That means 10k is equal to 1. So, what is the value of k, sir? K is 1 by 10. Problem is done. Sorry. Where it is running? K is equal to 1 by 10. Yeah. So our job is simply finding the k value. Now they may ask you, this is first question, but they may ask you like, what is probability that 1 less than or equal to x less than or equal to 3? They'll ask you this question. Just find probability that random variable should take values from where to where, sir? It should take value from 1 to 3. Inclusive, both inclusive. That is P1 plus P2 plus P. See, when it is discrete, that less than or equal to matters. That less than or equal to matters. So what happens here? P1 is K, 2K, 3K. So what is it, sir? 6K. That is 6 by 10. 9 by 10 is less than or equal to... Achha, 3 now, sorry. Oh, sorry. 2K we should start from, I am sorry. Okay, sorry. I wrongly written. PK. 1, 2K plus 3K plus 4. Read carefully. So 9K, that is 9 by 10. Good. You are correct. I am wrong. No problem. Right. No. Mukhopadhyay, I am wrong. Mukhopadhyay, I am wrong. Telugu nada. Right. Hope you understand. Is the idea clear? Now, you can also expect questions like conditional probability. What is probability that x greater than or equal to 1 given that x is less than or equal to 3? Even this type of problems. See, they are all problems. We just need to understand what we done earlier. The same things will come here also. Nothing will go beyond that. Am I clear? So people solve them as separate problems. If you understand from this, you can solve many problems. The entire story of distributions can be understood here itself. Now what is it? X greater than or equal to 1 given that x is less than or equal to 3. See, x is less than or equal to 3 means good. So what we do? We'll make a change. Less than or equal to 2, I do it. It is same as previous problem. Yeah, I changed it to the problem. Right. Now what is probability that x greater than or equal to 1 given that x is less than or equal to 2? I changed the problem, sir. SWFS is very quick, sir. Very good. So here, given that this happened, so it is like, probability that x less than or equal to 2, and here it is x greater than or equal to 1 and x less than or equal to 2. That is probability that 1 less than or equal to x less than or equal to 2 given that probability that x less than or equal to 2. See, x less than or equal to 2 means up to here, which is 6k, and 1 to 2 means it is 5k. So the answer would be 5 by 6, my dear friends. So what is the answer? Babu, SWS, you missed the conditional probability topic. I know that conditional probability people ignore. They want to do only advanced probability. Some people directly start with advanced probability. Okay, you should not miss the basic idea, sir. This is basic concept. Conditional probability. Conditional probability is what? Probability of A given B is probability of A and B by probability of B. That's it. Hope you understand. So here the sample space will be this one. Sample space will be this one, x less than or equal to 2. That is 0, 1, 2. It's not 1. Am I clear? So that changes. Got it? Please remember this. Good, sir. One more homework problem. Please write the answer in the comment box. I'll give you hint. Hint I'll give you. Don't write in the chat box, in comment box only. I want answers in the comment box only. A dice is loaded so that probability of getting face X is proportional to X. See, this statement This statement is actually definition of PMF. The PMF is defined by this statement. That is, what is Px, sir? Using proportionality constant, it is Px is equal to Kx. He given the probability mass function to you. He given it by this definition, by this statement, he given PMF. Okay. So, PMF is given, and because random variable means here what happens? Probability of getting phase x equal to x. So, here dice is rolled. This is your random experiment. And what is the random variable? Phase value. X is the phase value of dice. Everything is in the problem statement. We need to understand that. Without understanding, you solve it. Okay, still we can get the answers, sir. But this is important. Without understanding random variable, how can we solve problems on random variable? Am I clear? That's it. Nice. So that is phase value of x. Now probability of x taking the value x is equal to kx. And what are the possible phase values, sir? When you roll a die, the possible phase values are 1, 2, 3, 4, 5, 6. Then what is probability of x? Kx. That is k plus 2, k plus 3, k plus 4, k plus 5, k, 6. So from this you find the value of k. That is the first thing. Then second thing is probability that we get even number. So probability of even number means you want probability of 2 or 4 or 6. So this is what he is expecting, my friends. So please answer this question. I given required hint for this problem. Solution slide also leaving for you. Now probability density function. You already seen, right? Telephone call duration, x is the random variable, the value, that is xk takes values from 0 to infinity, the PDF, and you not created, I not created it, he given it, we are using it, but we don't know how to create it. That is a modeling part. But what we know is, we know about this particular probability density function, means we know the properties of the function. We don't know how to create the function, but we know the properties of the function. What are the properties? If x is a continuous random variable, the probability density function is defined in such a way that it should be a positive function. Because, okay, dx I missed it, sir. Oh, please don't miss that. Integral minus infinity to plus infinity fx dx must be equal to 1. Am I clear? So, probability density function, of course, we have a formal definition of that, ignore that. But whatever way it is defined, it should be positive. And it should be in such a way that minus infinity to infinity fx dx must be equal to 1. Here minus infinity to plus infinity, we need to understand it as a domain. For example, in the telephone call duration problem, the domain is from 0 to infinity. In that particular problem, 0 to infinity fx dx must be equal to 1. It is general domain, my dear friends. Generally it is minus infinity to plus infinity. Suppose you may be having a problem where x values are taken, that is x is taking values in an interval from 1 to 5. Then we have to write 1 to 5 fx dx must be equal to 1. That's it. Am I clear? And we don't know how to create it, but we know the properties of this. We know the properties of this particular function. So suppose if he says that x is the random variable and he says that this is your probability density function. Are you going to use it or not? He says that this is your random variable which takes values from 0 to infinity and gx is the probability density function. Are you going to use it or not? Are you going to use this particular probability density function or not? Are you going to scold this fellow? Are you going to use it blindly? Are you going to use it because you don't know how to create it? We may not know how to create it, but we know the properties. What is the first property? Whatever PDF is there, it should be positive. Is the first property satisfied by this PDF? Is the first property satisfied? No, because it is becoming negative. So if he says it is PDF, you tell him, idiot, give me proper PDF. because we don't know how to create it, but you know the properties. You know the properties, so he cannot cheat you. He need to give proper PDF. And second thing which we know is the integral from minus infinity to plus infinity fx dx must be equal to 1. So that is what I am trying to say. We don't know how to create it, but we know the properties. They cannot give anything and ask you to use it. We should know the properties of that PDF. We know the properties of PMS, we know the properties of PDF, and we use it. Is the idea clear, Babu? Is the idea clear? And one more important thing is, in discrete distribution, probability that x takes values from say a to b both inclusive, you say pa plus 1, pa plus 2 up to pb you do it. But here, what about probability that x takes values from a to b? Because you don't calculate point wise, right? See, actually at a point, probability for a continuous random variable is negligible. Okay, it may be taken as 0 also, but we generally don't say 0, we generally say it is negligible. That's why it is taken as 0. It is 0 because of that it is not negligible, sir. It is negligible, that's why we take it as 0. Am I clear? Probability at a point. That is, what is the probability that the telephone call duration is exactly 2 minutes? That exact values we cannot find it, sir. Even if sometimes they ask you exact values, we take a unit interval, that is, probability that it takes exactly 5 hours. For a continuous random variable, we take 4.5 to 5.5 probability we find it. So that will approximate probability at that particular point. That is how we calculate probabilities for continuous random variable. Am I clear? Strictly speaking, probability at a point is 0. But if at all, there are certain type of, because we model your problem with normal distribution or some type of distributions, in such cases, we need to find probability at a point. In such cases, we use this idea, my dear friends. Am I clear? Right. Now, when he says probability that a less than x less than b means we just integrate from a to b. Because when you say that it is PDF, what is that we know, sir? The area under this curve must be equal to 1. Because you integrate from here to here, that area must be equal to 1. And if you want from a to b, if you want this particular area. So you just integrate from a to b, my dear friend, you are going to get that particular value. And remember one important point, my dear friends. Remember one important point. When it is a continuous distribution, whether you write less than or equal to or not, it does not matter. Because whether it is less than x or less than or equal to x, it hardly matters. Even this fellow, they ask a less than or equal to x less than b, or if they ask a less than x less than or equal to b, they are all same, my dear friends. For continuous distribution, they are all same. But for discrete distribution, all these are different. All these are different for discrete. But for continuous, they are all same. They are all same. Hope you understand. Is the idea clear? Nice. Now look at this. Now, lifetime of an electric bulb is a random variable with a density function he given it, where x is measured in years. So obviously measured in years means number of years cannot be negative, x is greater than or equal to 0. Okay? And here, he also mentioned that if minimum and maximum lifetimes of the bulb are 1 and 2 years, that means the lifetime of an electric bulb. So here, the random variable is lifetime of an electric bulb in years, and this is the random variable, and for that the minimum and maximum is 1 to 2 years. That lifetime is actually given from 1 to 2 years only. Okay, and probability function is defined as kx square, and it goes only from 1 to 2 because he clearly mentioned what is the minimum and what is the maximum value. So out of that, the other side it is taken as 0, this side also it is considered as 0, my dear friends. The lifetime is 0. Got it? Because it is PDF. What should happen, sir? Integral minus infinity to infinity fx dx must be equal to 1. Am I clear? But as I told you, the domain is only from 1 to 2. Just integrate from 1 to 2. What is fx kx square dx must be equal to 1. See, I am simply using the function which he given. See, that's what I am saying, sir. Infinity to, I am not even taking minus infinity to 0. I am taking minus infinity to plus 1. Because in the problem, he clearly mentioned the minimum and maximum values. The random variable taking values from 1 to 2 only. Remaining cases, the value is not there, 0. Remaining cases, because it cannot be negative, remaining cases it is considered to be 0. That is how I am taking it as 0. Is that clear, Murali? So what is it? K into x cube by 3, limits are from 1 to 2, this should be equal to 1. Or you can type k by 3, 2 cube that is 8, 1 cube that is 1 is equal to 1. So what is the value of k, sir? 3 by 7. That's it. Super. I am just using the function which is given to me. I am just using the function which is given to me, sir. Hope you understand. Now sometimes, of course, even for discrete distribution also we can define this, what is known as CDF, that is cumulative distribution function. Cumulative distribution function means from starting to this particular value, what is the probability? Starting up to this particular value, what is the probability? Cumulative means up to here. Up to here, what is the probability? Suppose x is random variable, the cumulative distribution function of x is given by, see, up to x, what is the probability? That is probability that the random variable takes value less than or equal to small x. What is that? So just from, we assume that the domain is generally from minus infinity to infinity, no? So minus infinity to up to x, what is the probability? So that is what we call it as CDF multipliers. And this, you know that, you all know, right? Integration is reverse of differentiation. So if integral of this is equal to fx, then derivative of fx equal to small fx. So how the CDF and PDF are related, sir? The derivative of CDF is equal to PDF. And f minus infinity. That is, you are finding from minus infinity to minus infinity, the answer will be 0. And f infinity means up to infinity, the total probability, that would be equal to 1. Now this is very interesting. If you are finding probability that a less than or equal to x less than or equal to b, normally what you do? You do integral a to b fx dx. And this can be written as integral minus infinity to b fx dx, and this can be written as, okay, minus infinity to a fx dx. That is minus infinity to b, from that you are removing minus infinity to a, then you are going to get a to b. And this is nothing but up to b the probability, and this is up to a the probability. So we can use the CDF to find the probability directly with this formula by default. But for that you have to calculate this cumulative density function. Yeah, you can define it for both discrete as well as continuous, but generally we are not very much interested in discrete distributions. Okay, you can use it, there is nothing wrong. Up to that the probability, it gives up to that point probabilities it gives. Whether it is discrete or continuous, it should give you the probabilities by difference. But in the, it is only for this continuous case I given here. The formula which I given is for continuous case. Discrete case you have to worry about that less than or equal to and all. So that's why I not written that. I not written that. I written only for continuous case here. Is that clear? Hope you understand. Now this is a gate question. Continuous random variable x has probability density function given here. What is probability that x greater than 1? See, it is defined from where to where? 0 to infinity. What is probability that x, see the PDF he given, I have no objection, and I don't even ask what is the random variable. See, once PDF is given, you don't even have to ask what is that random variable, what is the original random experiment, everything is not needed. That's why, you know, most of the people, without even worrying about random variable, even when it is required, they solve problem by it. Am I clear? So here there is nothing required because x is continuous random variable and fx is PDF. He clearly mentioned use it. Now probability that x greater than 1 means, probability that x greater than 1 means you need to integrate from 1 to infinity fx dx. 1 to end. So that is 1 to infinity e power minus x dx. What is integral of e power minus x minus e power minus x? 1 to infinity. And you know, as x approaching infinity, e power minus x approaches 0. So upper limit will be 0, lower limit minus of minus plus e power minus So the answer is 1 by E for this. So the answer for this is 1 by E. I think I am covering the result. Is that clear? Right. Now, the same problem can also be solved using CDF. First, we calculate what is CDF. What is CDF, sir? Minus infinity to x fx dx. But see, your problem is defined from 0 to infinity. So, even though it is actually minus infinity to x, you have to convert it from 0. See that minus infinity is considered as the lower limit, plus infinity now is considered as upper limit. That you should remember, my dear friends. 0 to x e power minus x dx. So what is the integral? Minus e power minus x, limits are from 0 to x. So it is minus e power minus x, minus of minus plus, e power 0 is 1, so 1 minus e power minus x. So this is your cumulative distribution function or cumulative distribution function CDF. Now once you have this cumulative distribution function, if you ask this question, what is probability that x greater than 1? See, x greater than 1 means what, sir? 1 to infinity. So we are finding probability from 1 to infinity. Now according to this CDF formula, A to B, what is the answer? Capital FB minus capital FES. Similarly here, what should be the answer? Capital F infinity minus capital F1. But you all know capital F infinity means full probability. That is 1. And F1 means, because fxc already given, what is capital Fx? Which is 1 minus e power minus x. You can write 1 minus e power minus 1. 1 cancels, minus of minus plus e power minus 1, which is 1 by e minus x. So this is the basic idea of PMF and PDF. See, my dear friends, we are not creating them, we are using them. We are not creating, but we are using them, my dear friends. So you can try this problem as homework. You can try this problem as homework, my dear friends. And I want answer in comment section. Or you can join my Telegram group. There also you can send the answers, but I prefer answers in the comment box so that people who are watching this can understand that there are some problems to be solved. There are some challenges given to the students. They also can try those problems. Okay? It's an interesting problem. Please try this as homework, my friends. Actually, we are running short of time, but don't worry. Tomorrow I continue with the basic distributions. At least 1-2 distributions I discuss tomorrow. But for distributions, see, my dear friend, whenever you get any distribution, there is something called statistics comes into play. See, distribution or data, whenever you are having, we need to discuss the properties of the data, and the properties are given by statistics. Statistics gives you the quantitative measure. That is, with values you can tell the characteristics or properties of a data or distribution. Now why statistics now? Because here also we have distributions. When you have distribution, obviously statistics run to you. See, whenever you have some data or distribution, it can be probability distribution or it can be some biological or psychological or any type of distribution, people always run to statistics. Statistics gives you the properties, characteristics of the distribution. Am I clear? Now random process, we don't do it, sir. That is for electronics communication, in communications they might be doing, sir. We don't do random process here, sir. Random process is also very interesting, but we are not doing it. Okay? Okay, if any time permits, I may do it, but I cannot guarantee that, because in engineering mathematics generally, maybe for some parts they may be there, but for gate point of view, we don't do random process, okay, under this. Okay? So there are some definitions, please remember this. Tomorrow I'll start with this some examples, then we move on to some interesting distributions, maybe one binomial distribution and one uniform distribution I may discuss. Okay, tomorrow we'll discuss that. Expected value of a random variable is defined like this, sir. This is how we define expected value. Okay. See that expected value comes from the idea of averages only. So from that they define these expectations, mathematical expectation, and these expectations leads to the values called expected value of x square and other things, my dear friends. That is, this is actually expected value of x is called first movement. Then you can find second movement, third movement, and rth movement also. These higher order movements are useful for calculating higher order or different statistical measures. But in this course, we are only interested in two main statistical measures. One is called mean, the other one is called variance only. Okay, so we are only interested in up to the second movement, my dear friend. This is called first movement, sir. Sigma x into px when x is discrete, and it is integral x into fx. Okay, when x is continuous random variable. We can also define expected value of x square, sir. Same, in place of x we have x square. That's it. Am I clear? And in general, this expected value of x power r is called rth movement. See, the higher order movements are useful for finding the other statistical measures like skewness, kurtosis, etc. We are not getting into all that. We are only interested in up to second order movements because they are useful for defining the statistical measures. One is called mean and the other one is called variance. So the mean of a random variable is defined like this, which is simply expected value of x only. We denote it by mu, sir. Whereas variance of a random variable is defined as expected value of x minus mu whole square. But we don't use it. The simplified version is what we use for solving problems. So these are the two important formulae which we are going to use tomorrow, my dear friends. Am I clear? So I will not take up problems on this. Tomorrow I take up few problems on this expectations. Then we move on to the distributions. So that's all for today. If you have any doubts, you can ask me. Otherwise, I'll call it a day. Any doubts, you can ask me. Otherwise, I'll call it a day. Okay. So that's all. Tomorrow, same time, 7 p.m. we start with this problems on this statistical measures, mainly mean and variance, nothing more than that, for random variables, both discrete as well as continuous distributions ultimately. Then we move on to a binomial distribution. Two distributions I'll discuss. Okay, thank you.